Let's take a look at some applications of exponential growth and decay. Suppose you invest an amount of money, P, called the principal, which is compounded n times per year at an annual rate R. Let A be the amount after t years. To be compounded annually means that one time a year we calculate the interest. Semi-annually means 2 times a year the interest is calculated. Monthly means 12 times per year. Quarterly means 4 times per year. Weekly means 52 times per year. And daily means 365 times per year. We assume it's not a leap year. So here is your compound interest formula. A equals the principal times the quantity 1 plus the rate divided by the number of times it's compounded, all raised to the nt power. So you take the number of times it's compounded times the number of years, and that's your exponent. Let's take a look at our first example. Jess places $1,000 in a savings account which pays 6% interest. What is the value of the account at the end of 10 years if the interest is compounded semi-annually? Okay, well, if it's done semi-annually, that means that n would equal 2. We would do it twice a year, once every 6 months. 6% is as a percentage, and we want it as a decimal, so we're going to divide by 100 or move the decimal 2 places to the left to get 0.06. The $1,000 is the principal, the initial investment, and the time is 10. So if we plug into our formula, A equals the principal investment, $1,000, times 1 plus that interest rate as a decimal, 0.06, divided by the number of times it's compounded, all raised to the nt power, so 2 times 10. Now you can simplify a little, or you could type it exactly as you see it written in your graphing calculator. And so it's 1,000 times 1 plus 0.03 raised to the 20th power, or 1,000 times 1.03 to the 20th power. But at any rate, if you do it semi-annually, so if the interest rate is compounded twice a year, let's type that into our calculator, and we're going to round to 2 decimal places because we're discussing money. So if you correctly type that into your calculator and round to 2 decimal places, you should see that after 10 years of compounding twice a year, you would have $1,806.11. So you'll have nearly doubled your amount. Let's take a look at the next 2 examples. Let me just move everything up. Okay, so the next one says, what if we do it monthly? So now the number of times we compound is 12. Everything else will stay the same. So your total amount will equal that principal, 1,000, times 1 plus 0.06 divided by 12, all raised to the nt power, so 12 times 10, which means your exponent is 120, and you can enter it just like this into your calculator. You really do want to do it all at once so that you're not rounding in the middle and losing important value. Remember, we're talking about your money. You don't want to lose out on money. So you type that into your calculator. So you type 1,000 parenthesis 1 plus 0.06 divided by 12, close your parenthesis, press the caret key, type 120, hit enter. If you round correctly to 2 decimal places, you should get $1,819.40. Okay, well, what if we compounded daily? So that would mean that we'd compound 365 times. And we expect this to be the most amount after 10 years, because if we calculate interest every day, you're earning interest on your interest every single day. The more times we calculate interest, the better off it is. So n changes to 365, everything else remains the same. So principal is 1,000 times 1 plus 0.06 divided by 365, all raised to the 365 times 10 power. So you're going to type into your calculator 1,000 times 1 plus 0.06 divided by 365, all raised to the 3,650 power. And so if you correctly type that and round to 2 decimal places, you should get $1,866. I'm sorry, $1,822.03. So we can see, if you only compound semi-annually, you're still almost doubling your money after 10 years, which would be really nice. If you compound monthly, so 6 times as many compounding, or times we're going to calculate interest, you'll get, about $13.29 more. And if you compound every single day, you'll get the most, $1,822.03. Alright, our next example says, when she was born, Lucy's grandparents started a savings account for her so that when she became 18, she would receive $5,000 for college. If the bank paid 6% interest compounded monthly, how much did her grandparents initially deposit? So they're asking us to find the initial deposit, which is your principal, your P. 5,000 is going to be your total amount that you have at the end. 6%, again, as a decimal, we divide by 100, it's 0.06. Compounded monthly means n equals 12. They created it when she was born, and when she was 18, she received the $5,000, so that means that the time is 18. So her total amount is 5,000. We're looking for the principal, times 1 plus that interest rate as a decimal, divided by the number of times it compounded each year, raised to the nt power. So remember that this big crazy expression is just some number, and it's being multiplied by p. So to get p by itself, to solve for p, we need to undo this product. And so we're going to divide both sides by that expression. So we're going to divide by 1 plus 0.06 divided by 12 to the 12 times 18 power. And if we want, we can go ahead and figure out that. That's 216, so the 216th power. And we're going to take 5,000 and divide by that. And your graphing calculator can handle this. You can type it. Even the scientific calculator should be fine. Type in 5,000 divided by parenthesis 1 plus 0.06 divided by 12. Close your parenthesis and raise it to the 216th power. If you do that and correctly round to 2 decimal places, you'll see that they must have invested $1,702.55. Alright, so the next problem says Kyle places $1,000 in a money market fund which pays interest compounded quarterly. What is the value of the account after 20 years if the interest rate is 7%? So he placed $1,000, which means that's the principal. Compounded quarterly means n equals 4, t equals 20. And the interest rate as a decimal will be 0.07. So his total amount will equal 1,000 times 1 plus that interest rate as a decimal, divided by the number of times it compounds in a year to the nt power. So it's compounding 4 times a year, so it's quarterly for 20 years, which means your exponent will be 80. It'll calculate interest 80 different times. And so you can type this expression into your calculator. 1,000 times parenthesis 1 plus 0.07 divided by 4. Close the parentheses, raise to the 80th power. If you round that to 2 decimal places, you should get $4,006.39. So in 20 years, he'd quadruple his money just by sitting it in a bank that pays a pretty good interest of 7%. Okay, so one application of exponential growth was compound interest. An example of exponential decay is very similar. When a real-life quantity decreases by a fixed percent each year or other time period, the amount y of the quantity after t years can be modeled by this equation. Y equals your principal investment, which they're now going to use a lowercase a for, or your initial value, times 1 minus r to the t power. Essentially, it's the exact same as the compound interest formula. They just changed it to minus because now we're decreasing. So the value's not going up, it's going down. And the end value disappeared from here and here. And that's because we're going to calculate the value of the item only one time per year. So the end value that was being divided here and multiplied here is just 1. I know it's a little confusing, but now the a is a lowercase a, and it means principal rather than your total amount. The y is your total amount. And that's explained here. A is the initial amount, r is the percent of decrease expressed as a decimal, and 1 minus r is what we refer to as the decay factor. It's you take how much it's decreasing by, make it a decimal, and subtract it by 1 to figure out what percent you're keeping each year. So the first example says a new snowmobile costs $4,200. The value of the snowmobile decreases 10% each year. So as a decimal, that's 0.10. We divide it by 100. This is your initial cost for the snowmobile. So an exponential decay model, giving the value y in dollars after t years. Well, it starts out at $4,200. We're taking away 10% every year. So that's $4,200 times 0.9 raised to the t, meaning we keep 90% of its value every year. So if we want to estimate the value after 3 years, we'll take 4,200 times 0.9 to the third power. And again, we're still discussing money, so we're going to round to 2 decimal places. If you type that into your calculator, so 4,200 times parentheses 0.9, close parentheses raised to the third power, and round to 2 decimal places, you'll get $3,061.80. So it's definitely lost some value. Even in the first 3 years, it dropped by almost $1,200. Same thing holds true for a car. As soon as you drive it off the dealership lot, it is not worth the same amount of money. Unless you keep a car long enough for it to become an antique and really keep good care of it, it tends to be an investment you lose money on. So a new car invests $25,000, meaning that's your initial value. The value of the car depreciates by 15% each year, meaning that R is 0.15. So the exponential model giving the car's value after t years, well, it starts at $25,000. It's decreasing by 15% each year, so it's 1 minus 0.15 to the t power, or 25,000 times 0.85 to the t power. So you only keep 85% of its value every year. And if we estimate the value after 4 years, we type into our calculator 25,000 times parentheses 0.85 raised to the 4th. If you round to 2 decimal places, you should get that it would be worth $13,050.16. So even in the first 4 years, you've lost $12,000 in value. So when they talk about decay factor, this is what they're talking about, the 0.85 and the 0.9. That's your decay factor. It's the 1 minus the interest rate at which it's declining. So I'd like to take a look at one more example. This one is from the assignment that's found on pages 8 and 9 in your notes packet. It's problem 4. Suppose you have $2,000 to invest. In 4 years, you would like to purchase a new car, and you want a down payment of $3,500. What interest rate would you need to have if the interest is compounded monthly? So your total amount is going to equal the principal times 1 plus r over n raised to the nt power. Remember, that's our compound interest formula. So this is the amount you have to invest, so that's your principal. This is the amount you want, so that's your total amount. 4 years is your time. Monthly means n equals 12. So let's plug in everything we know. The total amount, $3,500. You want that to equal your principal times 1 plus, we're looking for the interest rate, so we're going to solve for r, divided by 12 to the nt power. So 3,500 equals 2,000 times 1 plus the rate divided by 12 to the 48th power. So you're going to start by dividing both sides by the principal. You're going to divide by 2,000 because this is a product, this times this, since there's no symbol in between. And so to undo it and break those apart and work your way toward the r, you're going to divide. So you'll divide by 2,000. So your zeros can cancel, and then you have 35 over 20, which can reduce. Both of them are divisible by 5. So you've got 7/4. Remember, you want to keep everything exact. So work in terms of fractions as much as you can. And then we're at this point, and now we're going to need to undo the power. If I want to continue working toward r, I've got to take the 48th root of both sides. So we've got to put what we learned in chapter 3 to work. So we'll do 7/4 to the 48th power, or 7/4 to the 1 over 48th power. Excuse me, I said 48th power, but I meant 48th root, or raise it to the 1 over 48th power. So when you do that, you should get 1.01173 approximately. And keep that entire value in your calculator so that we continue to work with it. You're going to take away the 1. So if you just hit -1, your calculator will automatically take your last answer and subtract 1 from it. You'll get 0.0117. And now I can see more of the decimal places, 27 approximately, equals r divided by 12. And we're keeping this entire value in our calculator because we want to work as precisely as we can, and we don't want to lose any value. So now to finish solving for r is being divided by 12, so the opposite is to multiply by 12. So on your calculator, just hit times 12. It'll automatically take your last answer and multiply it by 12, and you get this approximately, which means that the interest rate you need is 14%. Which would be very difficult to find. It's not very realistic, so you're going to need to work really hard and put in some more money if you want to make your goal of having $3,500 as a down payment in 4 years. So those are some applications of exponential growth and decay.